Alright, well, today in class we talked about the Bohr model of the atom. And the Bohr model was first developed by a man by the name of Niels Bohr, who was a Danish physicist who made some pretty important contributions to the understanding of atomic structure. In 1913 he developed his model of the atom. And it differed a little bit from Ernest Rutherford's model. Ernest Rutherford said that there was a small, dense, positively charged nucleus surrounded by electrons on the outside, moving around the outside of the nucleus. And Niels Bohr did some experiments looking at how light reacted with different atoms, and he determined that electrons actually moved in very specific energy levels, or orbitals he called them, energy pathways. And he came up with a very specific theory that we're going to take a look at today that will help us determine the atomic structure, and it leads us to a better understanding of atomic structure, and it gives us a better idea of why atoms behave and react the way they do. Okay. So on your worksheet that you picked up in class today, we're going to go over some of the main ideas behind Bohr's model. And then we're going to use the model to gather some information about elements 1 through 20. In fact, we're going to use the Bohr model and actually show the atomic structure for elements 1 all the way up to 20, which is calcium. Okay. So we're going to start with hydrogen as an example. And let's see. All right. So here's hydrogen on our chart, and if you look over here, this is the information for hydrogen off of the periodic table. There's a couple of things I want to point out. Before we can do with the Bohr model, we need some information about hydrogen. In the first place we're going to get the information is from this number in the upper left-hand corner. And this number here is called the atomic number. And the atomic number basically tells us the number of protons that are in an atom. And remember that protons have a positive charge. Okay, so we know just by looking at this number that hydrogen has one proton, one positive charge. And if you remember from class, we talked about the fact that atoms are, overall, they have a neutral charge. They are balanced. They don't have a positive or negative charge. So in order to balance this positive charge, we know that we also need to have an electron. And electrons have a negative charge. And so the atomic number is going to tell us how many protons there are, and we need to balance the number of positive charges with an equal number of negative charges. So this number actually also tells us how many electrons we have. So hydrogen, by looking at the atomic number in the upper left-hand corner here, has one proton, one positive charge, and one electron, one negative charge. So we almost have all the information we need in order to model the atomic structure of hydrogen using the Bohr model. But we're missing one subatomic particle, and that is the number of neutrons. Okay. To figure out the number of neutrons, we're going to look at this number down here on the periodic table, and that number there is the atomic mass. And the atomic mass basically is calculated by adding the number of protons with the number of neutrons. Well, we know how many protons there are by looking at the atomic number, so all we have to do is subtract the number of protons plus neutrons from the number of protons, and we're going to be left with the number of neutrons. So if our atomic weight is 1, which is the protons plus the neutrons, minus the atomic number, which is 1, then we're going to get the number of neutrons in this case, which is 0. So hydrogen actually is the only element, the only atom in its normal state that has 0 neutrons. So now we're going to take a look at the Bohr model. And the first thing we're going to do is we're going to fill in the information for the nucleus of the atom. So we now know that hydrogen has 1 proton and 0 neutrons. We also know that it has 1 electron. And we're going to fill in the electron. Now remember that Bohr said that electrons surround the nucleus in specific energy shells. So we need to go over a couple of rules. Okay. Bohr said that there are up to 7 energy shells surrounding the nucleus. And I'm showing you here, here's energy shell number 1, 2, 3, 4. So there's actually 5, 6, 7. There's 3 more energy shells that surround the nuclei of atoms. Okay, but I'm only showing you the first 4 because for our purposes, we're going to be modeling only elements 1 through 20. And so our atoms that we're going to be modeling only actually are going to go out to the 4th energy shell. Okay. According to Bohr, the lowest energy shell, the energy shell number 1, is actually the shell that has the lowest energy. Closest to the nucleus, it's also the smallest energy shell. And Niels Bohr said that this energy shell can fit 2 electrons, a maximum of 2 electrons. Okay. He then said that every other shell can hold a total of 8 electrons. Okay. So energy shell number 2 can hold up to 8 electrons, energy shell number 3 can hold up to 8 electrons, energy shell number 4 can hold up to 8 electrons, and so on, all the way out to energy shell number 7. Now he actually called this the octet rule, the word octet standing for 8. Okay? And he believed that 8 electrons filling each energy shell gives you a stable and a maximum number of electrons that can fit in that energy shell, with the exception of the first energy shell, which can only hold 2. Okay. Now you'll see in your notes, like I mentioned before in class, the Bohr model works really well for elements 1 through 20, but when you get into elements that are bigger than calcium, which is element number 20, Bohr's model doesn't really work anymore. And that's because his model is actually not 100% accurate. And that's where the modern model, or the quantum model, comes in. And you'll see here in your notes that energy shell number 3 can actually hold up to 18 electrons, and energy shell number 4 can actually hold up to 32 electrons. But we're going to save that for maybe later on when you get to high school. You're going to learn all about the modern or quantum model of the atom. But for our purposes this year, we're going to focus just on these first 20 elements. And so Bohr's octet rule holds up. Okay. So we're talking about hydrogen. We were getting all this information about hydrogen. We know that there's 1 proton in the nucleus. There are 0 neutrons, but we have 1 electron. Well, Bohr says that electrons are going to fill the lowest energy shell first. So I'm going to go ahead and shade in this spot where an electron goes. And now we see that we've filled in the Bohr model. Okay? And the really important thing that we can see is that hydrogen has 1 outermost electron. It has 1 electron in this energy shell. Okay? Well, this electron is going to play a very important role in how hydrogen behaves. And this electron is going to be called the valence electron. And down here, we're going to go ahead and define what valence electrons are. Okay. Valence electrons are the number of electrons in the outermost shell. These are the electrons that are involved in bonding with other atoms, and they determine how an atom behaves. Okay. So by doing the Bohr model, by showing the atomic structure using Bohr's theory, we can actually determine the valence electrons for these 20 elements. And it's the valence electrons that we want to know, because that's going to help us determine and make predictions about how atoms behave, which atoms they're going to bond with, what molecules they can form, and ultimately that's what we want to know. So on this assignment, we're going to be filling in this chart, and for each element, we're going to determine the number of valence electrons for each of these 20 elements. Okay. So on the back side of your worksheet, okay, I've given you sort of a little setup here that's going to help you use the Bohr model to figure out how many valence electrons each element has. Okay. Let's see here. So on the front side, I've actually given you the information for hydrogen, helium, and lithium. So let's go ahead and model those together. We just did hydrogen on the front side, so I'm going to go ahead and skip that one. Let's come over here to helium. Okay. Helium has an atomic number of 2, which means automatically I know it has 2 protons and 2 electrons. It has an atomic mass of 4, so 4 minus 2. Remember, the atomic mass is how many protons plus neutrons there are. And the atomic number is just the number of protons, so if I subtract the atomic mass from the atomic number, I'm left with just the neutrons. So there are 2 neutrons. So here I'm going to write 2p standing for 2 protons, 2n for 2 neutrons, and I know that I got a total of 2 electrons. Remember that according to the Bohr's rules, those electrons are going to fill the first energy shell. So 1, 2. Now that energy shell is full, and I've run out of electrons. So that's the total number of electrons that helium has. And now I'm going to look at the outer shell that has electrons in it. So that's just the first energy shell in this case, how many electrons there are, and there are 2. And so helium has 2 valence electrons. Okay. Let's look at lithium over here, element number 3. Okay. Lithium has 3 protons, 3 electrons. I know that automatically. Atomic weight minus the atomic number, so 7 minus 3 gives me 4 neutrons. Okay. So in the nucleus, I'm going to write that there are 3 protons, 4 neutrons, and now I have to fill in the 3 electrons. First 2 electrons go into the first energy shell. That energy shell is now full. Remember that the first energy shell is the exception to the octet rule. It is full with only 2 electrons. The third electron I'm going to put here in the second energy shell. Okay. Now by looking at this model, I'm going to look at the outermost energy shell that has electrons in it, so the second energy shell, and there's only 1 electron there. So lithium has 1 valence electron. Okay. We also notice, if you remember from the first side, that hydrogen has 1 valence electron. It has 1 proton, 0 neutrons, and 1 electron. So that 1 electron is in the first energy shell, so it has 1 valence electron as well. I wonder if we're seeing the beginning of a pattern here. Okay. Let's come over here and do one more example, and then I'm going to let you do the rest on your own. Okay. Let's take a look at boron. Okay. Element number 5 is boron, and it has the atomic number 5 and an atomic mass of 11. So automatically I know that it has 5 protons, 5 electrons. I'm going to take a look at the atomic mass, 11, minus the atomic number, which is 5, and it has 6 neutrons. Okay. The nucleus, I'm going to write 5p for the protons, 6n for the neutrons, and now I'm going to fill in these 5 electrons. First 2 electrons go in the first energy shell. That energy shell is full. I have 3 more electrons, so I'm going to put 1, 2, 3. Okay. Now I'm going to look at the outermost shell that has electrons, so that's the second energy shell, and I'm going to count them up. 1, 2, 3. And boron has 3 valence electrons. So I'm going to flip over to the other side. Element number 5 is boron. It has 5 protons, 5 electrons. And if you remember from the back side, whoops, erased. Okay, so 5, 5, and then 6 neutrons, and we discovered that it has 3 valence electrons. Well, that's it for what I'm going to show you, and if you can now use this information and fill in the rest of this chart on your own, and fill in the back side of this, this worksheet as well.